Okay, let's dive right into this explainer and explore how we can finally bring some order to the absolute chaos of AI coding assistants in Java development. If you've been using tools like Cursor, Claude Code, or GitHub Copilot, you already know they are incredibly powerful. But let's be honest, they also introduce an entirely new class of headaches when it comes to managing exactly how they interact with your specific code base.
Think about it. You might have multiple different AI assistants running in your repository right now. Keeping them from wandering into places they absolutely shouldn't be is just a massive struggle. How do you stop an eager AI from trying to clean up a hyper-fragile legacy payment processor? Or, even worse, how do you guarantee it won't accidentally start logging personally identifiable information, causing a massive, immediate compliance nightmare? Traditionally, we've relied on project-level text files to give these agents instructions. But, well, that approach has a fatal flaw.
The problem is that disconnected text files suffer from configuration drift. When developers refactor code or rename a package, they almost never remember to update that random markdown rules hidden away in the root directory. VibeTags completely flips this model on its head. They are compile-enforced metadata directly attached to the Java source code they're meant to protect. So if you move the class, the rules move right along with it. So, here's our game plan for today. We are going to unpack the problem of rule staleness, look at the vibe tag setup, dive into protection and security, cover design intent, map out the implementation workflow, and wrap up with CI enforcement. Let's get to it. Setting this up is crazy fast, literally less than 60 seconds with 4 simple steps. You just add the dependency, drop in an empty placeholder file for whatever platforms you use, like a blank .cursor rules file, annotate your code, and hit compile. VibeTags uses the Java compiler itself to do all the heavy lifting. It gathers your annotations and generates the exact files your AI platforms expect. Best of all, absolutely zero runtime overhead. All right, Section 1, Protection, Security, and Compliance. Let's see how VibeTags basically builds a fortress around your most sensitive code, starting with some basic access control. Let's look at our core protection tags. These give you the power to explicitly control AI access. We have @AI-locked, which flat out prevents any modifications to critical code, like your crypto algorithms. Then there's @AI-ignore, which just hides generated or deprecated files from the AI entirely. We've got @AI-legacy bridge for those compatibility shims you definitely don't want fixed, @AI-callers only, so maybe only an auth service can call a specific token generator, and @AI-sandbox only to make 100% sure your mock test data never leaks into production pathways. To put this into perspective, think about an ugly but totally necessary workaround for an upstream library bug. You can stop an AI from trying to refactor it simply by slapping the @AI-legacy bridge annotation on it. It explicitly tells the AI, hey, leave the structure alone, it exists for a reason, but feel free to update the internal business logic. Moving beyond basic locks, these security and compliance annotations are absolute game changers. For instance, @AI audit forces the AI to check for specific vulnerabilities like SQL injections on every single change. @AI privacy guarantees personally identifiable information isn't reproduced in logs. @AI regulation ties your code directly to GDPR or PCI DSS compliance clauses. We also have @AI input sanitized to demand access checks, @AI secure logging to explicitly ensure the AI masks a credit card string, and @AI secure to mark core crypto and off paths that need extreme caution. Now, what's really cool is when you combine them. If you place both @AI audit and @AI privacy on a payment processor class, the AI is structurally barred from accidentally leaking a user's credit card data into a test fixture or a logging statement. Plus, it's actually forced to explicitly state that it audited its own changes. Airtight security. Moving right along to Section 2, Design Intent and Behavior. The perimeter is secure, so now we need to look at how VibeTags enforces your architectural vision. This is where we lay down the architectural law. With @AI architecture, we enforce strict package layering. @AI core warns the AI to treat sensitive core business logic really carefully. Digging deeper, @AI domain model prevents the AI from polluting clean domain layers with random JPI imports. You can also demand open-closed principles with @AI extensible, require final fields for safety with @AI immutable, preserve lock-free or synchronized invariants using @AI thread-safe, and ensure backward-compatible additive-only changes with the @AI public API annotation. On the operational side, this set of strict enforcement tags makes sure the AI respects all your specialized boundaries. @AI schema safe is a hard stop against destructive database column drops. You can outlaw lazy exception swallowing with @AI strict exceptions, or stop the AI from using loose maps when a strong domain object is needed with @AI strict types. We enforce translation bundles with @AI internationalized, protect your SO-load dashboards by preserving metric names with @AI observability, and use @AI's strict class path to outright forbid the AI from pulling in custom class loaders or external reflection hacks. Seriously, think of how much time you're going to save during code reviews when the AI automatically knows not to propose destructive database migrations or muddy up your clean architecture just because it found some fast shortcut online. It literally eliminates an entire category of frustrating back-and-forth prompting. Finally, for behavioral lifecycle management, we've got a fantastic suite of tools. @AI Contract freezes a method's public signature while letting the AI optimize the insides. We can set strict Big O time limits with @AI Performance, demand zero allocation limits with @AI Memory Budget, and enforced deterministic side-effect-free logic with @AI Pure. For routing, @A Deprecated actively tells the AI to migrate callers away. @A Sunset acts as an ultra-strict block on any new references, and @A Temporary triggers compile time warnings when a hotfix passes its expiration date. This specific combination perfectly balances stability with optimization. By pairing contract and performance, you're telling the AI, sure, rewrite the guts of this hot path method to make it way faster, but you absolutely cannot touch the public interface. It's brilliant for preventing cascading breakages across all your API consumers. All right, Section 3, Implementation and Lifecycle Workflow. We've mapped out our constraints, so let's explore how to actively guide the AI's workflow. These workflow tags act as direct, source-controlled prompts. @AI Context gives positive or negative guidance on which external libraries to favor or avoid. @AI Draft leaves instructions for the AI to finish an incomplete class. @AI Test-Driven is huge. It forces a red-green refactor loop. @AI Explain actually demands mathematical or architectural chain-of-thought reasoning before the AI applies a modification. And @AI Indopotent guarantees that an operation, like a payment charge, remains completely safe to retry without compounding side effects. So the key takeaway here is that by dropping the @AI test-driven tag on a class, the AI itself becomes your own personal accountability officer. It will simply refuse to submit business logic changes to you without simultaneously proposing the accompanying JUnit 5 test coverage that you demanded. How great is that? To wrap up our tour of all 39 annotations, we have some specialized workflow flags. @AI Parallel Tests ensures any tests the AI generates are thread-isolated with no shared mutable state. @AI Prototype tells the AI it can relax those strict rules for a rapid disposable spike, just as long as it doesn't leak into production. And @AI Feature Flag tells the AI to explicitly preserve conditional routing. By using that feature flag annotation, you prevent a really common AI hallucination. It stops the AI from accidentally hard-coding a beta feature to true, or just stripping out the conditional guard entirely during a routine refactoring session. And finally, Section 4, CI Enforcement and Takeaways. Let's see how this all builds into an unbreakable, automated safeguard for your whole team. VibeTags isn't just about local suggestions on your laptop, it's about real CI enforcement. By running VibeTags in check mode during your continuous integration pipeline with just a simple compiler argument, you guarantee that if a developer manually edits an AI config file and it drifts from the source annotations, the build just fails. Done. Plus, there's a custom GitHub action that will outright block any pull request if it attempts to alter code marked with the @AI lock tag. Okay, here is the absolute most crucial takeaway from all of this. Your annotations are strictly evaluated at compile time. Because they use a source retention policy, they are completely stripped away before bytecode generation. You get perfect AI alignment across 43 different AI platforms, updating Cursor, Claude, Copilot, and more, all at once. And you pay exactly 0 runtime penalty for it. The tools to securely harness AI coding assistance without sacrificing a single ounce of software engineering rigor are finally here. No more staleness, no more context drift, and absolutely no more silent AI regressions. So the question is, will you continue letting disconnected text files compromise your code base, or are you going to start compiling your AI rules directly into your source code today?